This video is about inverse functions. This is AP Precalculus topic 2.8. If you appreciate this content, please give it a like. Find the inverse relation for each of the relations below. You can find the inverse relation by switching the x's and y's. So here's the inverse relation for number 1, and here's the inverse relation for number 2. For the given functions below, sketch the inverse function on the same axes as the original function. The inverse graph will be the reflection over the line y equals x. Therefore, any point on the original function that is on the line y equals x will not actually move. So this point right here will also be a point on the inverse graph. A key point on the original graph is the point -4, 3. The corresponding point on the inverse graph will be what we get when we switch the x and the y. So the corresponding point on the inverse graph will be the point 3, -4, which is here. Another key point on the original graph is the point 0, 1. This will correspond to the point 1, 0 on the inverse graph. So that's going to be right here. The next key point on the original graph is the point 1, -2. This will correspond to the point -2, 1 on the inverse graph. So that will be right here. The final key point on the original graph is the point 4, -4. This will correspond to -4, 4 on the inverse graph, and that's going to be right here. Connecting the points in a similar way as the original gives us the inverse graph. Number 4. Let's graph the inverse function by reflecting over the line y equals x. Everything that is touching the line y equals x will not move. There are many points on the original function that fall on the line y equals x. This closed circle, the open circle, everything in between, this point right here, and the end point. So all of the points that I just colored in red will be points on the inverse function. In addition, the key point -1, 0 on the original function will correspond to the point 0, -1 on the inverse function. Here's the point 0, -1. Next, the key point 2, 1 on the original function will correspond to the point 1, 2 on the inverse function. The point 1, 2 is right here. Connecting the points in a similar manner as the original function completes the graph of the inverse function. Find the inverses of the following functions. F of x is another name for y. The first step of finding the inverse is to switch x and y. So we get x is equal to 3y plus 5. Now we must solve for y. Subtracting 5 from both sides gives us x minus 5 is equal to 3y. Dividing both sides by 3 gives us x minus 5 over 3 is equal to y. Finally, if the original function was named f of x, we must name the inverse function f inverse with a -1 superscript. Number 6. The first step is to switch x and y. So we have x is equal to -2y plus 7. Now we must solve for y. Subtracting 7 from both sides gives us x minus 7 is equal to -2y. Dividing both sides by -2 gives us x minus 7 over -2 is equal to y. I'm just going to flip this around and put the negative in front, and that gives us y is equal to negative x minus 7 over 2. Let's find the inverse for k of x. The first step is to switch x and y. K of x is another name for y. So switching x and y gives us x is equal to 2/3 y minus 1. Now we solve for y. So adding 1 to both sides gives us x plus 1 is equal to 2/3 y. Multiplying both sides of the equation by 3 will give us 3x plus 3 is equal to 2y. Dividing both sides by 2 gives us 3x plus 3 over 2 is equal to y. Since the original function was called k of x, we must call the inverse relation k inverse of x. Find the inverse of the following functions. Be sure to show all work and use proper notation. So, finding the inverse of a rational function, a function whose numerator and denominator is a polynomial, has a few extra steps to it, and we should begin by listing out any restrictions on the domain. For f of x, x cannot equal negative 2, because if x was negative 2, we would have negative 2 plus 2, which would give us 0 in the denominator. Dividing by 0 is undefined. If you are ever unclear of the restrictions, start by setting the denominator not equal to 0 and solving for x. So this would give us x cannot equal negative 2. F of x is another name for y. As before, the first step is to switch x and y. So this will become x equals y minus 3 over y plus 2. The next step is to eliminate the fraction by multiplying both sides of the equation by the denominator. On the left side, I'm going to distribute this x, so I get xy plus 2x equals. On the right side, the y plus 2 cancels out, and we just have y minus 3. Now our goal is to get all of the terms with y in it on the left side of the equation. So I want these two terms on the left. Every term that does not have y in it should be on the right side of the equation. So I want this term and this term to be on the right-hand side. On the next step, I will move this term to the left by subtracting y from both sides, and I will move this term to the right by subtracting 2x from both sides. So now we have this. The point of getting all of the y terms on the left side of the equation is so we can factor the y out, like think GCF. So if I factor the y outside of parentheses, on the inside I'm going to have x minus 1. If you have trouble understanding where the x minus 1 is coming from, all we are really doing is dividing each term by the common factor we just pulled out. If we divide x minus y by y, the y's cancel out and we get x. If we divide y by y, well, that's 1. And we just bring down the negative 2x minus 3 on the right-hand side. Now we can get y completely by itself by dividing both sides of the equation by x minus 1. So if we divide by x minus 1 on the left and on the right, these will cancel out and we will be left with the final answer. Since the original function was called f of x, we should call the inverse f inverse. If this was a multiple choice question, you might see the negative factored out and put in front of the fraction like this. So whenever you have a leading coefficient that's negative, be prepared for that negative to be factored out and put in the front. Let's find the inverse function for h of x. Let's begin by stating the restrictions. 2x plus 3 cannot equal 0. We can't divide by 0. Subtracting 3 from both sides tells us that 2x cannot equal negative 3. And dividing both sides by 2 tells us that x cannot equal negative 3 over 2. After stating the restrictions, the next step is to switch x and y. So we will have x is equal to 4y minus 1 over 2y plus 3. Now we must eliminate the fraction by multiplying both sides of the equation by the denominator. So we multiply both sides by 2y plus 3. On the left side, I'm going to distribute this x. So I'm going to get 2xy plus 3x equals. On the right-hand side, the 2y plus 3 will cancel out, and I'm left with 4y minus 1. We need to get all of the terms that have a y in it on the left side, and all of the terms that don't have a y on the right-hand side. So I'm going to move this 4y over to the left by subtracting 4y from both sides, and I'm going to move this 3x over to the right by subtracting 3x from both sides. Now that the y terms are together on the left, we can factor out the common y and put it in front of parentheses like this. On the inside, we will be left with 2x minus 4. And we bring down the negative 3x minus 1. Finally, we can get y by itself by dividing both sides by 2x minus 4. This is the inverse relation. However, since the original function was called h of x, we should call the inverse h inverse. Also, because the leading term is negative, it is common to factor out that negative. So I'm going to temporarily show you. If we bring this negative outside of the parentheses, you can probably see how we would get this. However, it is most common to put this negative in the very front of the fraction. So, on a multiple choice question, you would likely see the answer presented like this. Number 10. Let's begin with the restriction that x cannot equal 5, because if it did equal 5, we'd have 5 minus 5, and we'd be dividing by 0. We can't do that. The next step is to switch x and y. So we have x equals y plus 4 over y minus 5. Now we can eliminate the fraction by multiplying both sides by y minus 5. We multiply by that denominator. I'm going to distribute this x now. Distributing the x gives us xy minus 5x equals. On the right hand side, the y minus 5's cancel out, and we just have y plus 4. We need every term that has a y in it on the left side of the equation, and every term that does not have a y in it on the right side of the equation. So I'm going to move this y over to the left by subtracting y from both sides. And I'm going to move this negative 5x over to the right by adding 5x to both sides. My ultimate goal is to solve for y. It's no good to have y in two different places. I can make y land in one position by factoring a y out. It's a GCF. So if I pull y outside of parentheses, I'm going to be left with x minus 1. Just one more time, when I bring the y out, I am really dividing by this common factor to understand what lands on the inside of the parentheses. Y minus y, these cancel out and leave x, bring down the minus, and then y divided by y is 1. We can get the y completely by itself by dividing both sides of the equation by x minus 1. So we will end up with y equals 5x plus 4 over x minus 1. So this is the inverse function. The original function was called y, so we don't need to change the name of this. Actually, let's call it y inverse and give it the -1 superscript. For number 11, the first step is to state the restrictions. We know that the denominator cannot equal 0. Subtracting 7 from both sides, we get 3x is equal to -7. Well, 3x cannot equal -7. Dividing both sides by 3, we see that x cannot equal -7/3. To find the inverse, we switch x and y. So we will have x is equal to 2y plus 1 over 3y plus 7. Next, we eliminate the fraction by multiplying both sides of the equation by the denominator. So I'm going to multiply both sides by 3y plus 7. On the left-hand side, I am going to distribute this x. So I will end up with 3xy plus 7x. On the right side, the 3y plus 7 cancels out with the other 3y plus 7, and I'm left with 2y plus 1. I need every term that has a y in it on the left side of the equation, and every term that does not have a y must be on the right side of the equation. So I'm going to move this 2y over to the left by subtracting 2y from both sides, and I'm going to move the 7x over to the right by subtracting 7x from both sides. Now that I have all the y terms on the left side, I can group the y's into a single factor by factoring out the common y. So I'm going to bring the common y outside the parentheses like this. To understand what goes inside the parentheses, we are just dividing each term by the common factor that we are pulling out. When you divide by y, these cancel out and that just leaves 3x. Bring down that minus sign. These y's cancel out, leaving a 2. And this is equal to negative 7x plus 1. To get y completely by itself, we will divide both sides of the equation by 3x minus 2. This will leave us with negative 7x plus 1 over 3x minus 2. This is the inverse, but I'm going to make two changes. Since the original function was called g of x, we should call the inverse function g inverse. Also, because the leading term is negative, I'm going to factor this negative out. This is not 100% required, but this is very common. So you can imagine if I take out this negative sign, I will have negative and then 7x minus 1 over 3x minus 2. But what is even more common is they love to take this negative sign and put it in the very front of the fraction like this. So on a multiple choice question, this is what you would most likely see for your answer. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.